You've been lowing like crazy late night.
Yeah, you look like you haven't slept in a week. Are you pulling another all-nighter?
I'm not doing well, just trying to crack all this stuff about metabolism. And honestly, fried, it's like every time I get through one pathway, I hit another one and then I get lost all over again.
Carb metabolism is a beast, for sure. But you know, if you break down it into pieces, it starts to make sense. Like, you could start with the Pentose Phosphate Pathway. It sounds complicated, but it's really not so bad once you get the basics.
Yeah, the Pentose Phosphate Pathway has two parts. So the oxidative and non-oxidative stages. The oxidative stage is all about generating NADPH and ribose phosphate, which is basically what you need for making nucleotides. It's like the raw materials for building DNA and RNA.
Then in the non-oxidative stage, you are shuffling around sugars, conjugating things like ribose 5-phosphate into other sugars. That part helps balance out the sugar levels, so things like glycolysis can keep moving smoothly.
Oh, I think I remember that. It's just this back and forth with sugar and coenzymes that throwing me off.
Trust me, it gets easier once you connect the dots. So usually, the think of glucose metabolism like a flow chart. You start with glucose, break it down into glucose 6-phosphate. Then either store it as glycogen or use it in glycolysis. It's about balancing storage and energy production.
Exactly. It's all begin with digestions, right? We start by breaking down carbs into glucose in the digestive system. Once glucose enters your bloodstream and taken up by cell and converted into glucose 6-phosphate, this step is crucial because it traps glucose inside the cell so it can be used for energy.
Once glucose is converted into glucose 6-phosphate, it can either go into glycolysis for energy production or be stored as glycogen. If you're not using it right away, the body stores is a liver and muscle through a process called glycogenesis. That's how you build up your glycogen reserves for later.
When your body needs glucose again, say between meals or during exercise, it breaks your glycogen back into glucose. That's glycogenolysis. It's like your body ways of toppings into backup supplies.
Once glucose enters glycolysis, it gets split into pyruvate. Pyruvate, like the crossroads, it can either enter the citric acid cycle or be converted into lactate under anaerobic conditions. So this is where your body starts to generate energy.
Right, and from there, pyruvate is converted into acetyl COH, which enters the citric acid cycle. That's where you are get most of your ATP along with NADH and SADH2, which are used in the electron transport chain to make even more ATP.
Exactly. And don't forget glycogenolysis. That's like the reverse of glycolysis when your body needs to make glucose from scratch, like in between meals or during fasting.
Oh, I get it now. I just need to piece it all together, but I always forget how hormones come into play.
Yeah.
Yeah, hormones are the control center. Insulin is the big one. It tells your body to store glucose. When you eat makes you sure your body not flowing with glucose. Then glucagon does the opposite. It triggers to the liver to break down glucagon into glucose when you're fasting.
And epinephrine, when you're stressed or exercising, helps release glucose into the blood for a quick energy boost. It's like your body's emergency response system.
They all work together to keep your blood sugar in check, which is easy pretty to how well you're functioning. If in any of these, hormones get out of balance, things start to go sideways.
And then, of course, there are B vitamins. Those are crucial for all these metabolic reactions, like niacin. Your body uses it make NAD plus and NADH, which are vital for energy production. NADH is used to the electron transport chain to make ATP. Without NADH, you would be able to efficiently produce energy.
Riboflavin does the same thing with FAD, helping to fuel the electron transport chain as well. Both NADH and FADH2 carry electrons to the chain where the magic happens and you get tons of ATP.
Thiamine is another big one. It involves in the carboxylation reaction in the citric acid cycle. Specifically, thiamine as TPP helps in the conversion of pyruvate to acetyl CoA, which is key for energy production.
Pantothenic acid is another vitamin you shouldn't forget. It's precursor to enzyme A, which is needed to form acetyl CoA. If you don't have enough of that, your entire energy production slows down.
And biotin is important too. It helps with carboxylation reaction so your body can make glucose when it needs it, particularly in gluconeogenesis.
Don't forget about vitamin B6. It's essential for amino acid metabolism and helps in the production of neurotransmitters. It inherently impacts carbohydrate metabolism, especially when you're breaking down amino acids feed into the citric acid cycle.
Oh, so what I'm hearing is my tiredness might be more than just studying too much. If any of these pathways are off, it could mess with my energy levels.
Definitely, it's all control if you're not getting enough of the vitamins or if your hormones are in a balance. It could definitely affect how you feel.
So, yeah, maybe take a nap between studying and hydrate. Your body is a machine, but every machine then rest.
Fair enough, I guess it's time for a quick break and some food then. Thanks guys, I'm feeling a bit better about this now.
You got this! Now, just remember to breathe and take it step by step.